Hello, Math 141. Let's solve some logarithmic equations. Let's start with something easy. Log of x plus log of x minus 21 equals 2. Just a reminder that if you don't see any base, that means that this base is 10, and so is this base. First thing I'm going to rewrite is I'm going to just write this as log base 10 of x times x minus 21 equals 2, and I can simplify that to log base 10 of x to the second minus 21x equals 2. Now I can claim that this base to this power, that is 10 to the second power, must equal this argument, x to the second minus 21x. 10 squared is 100. Putting all terms in one side, I will get x to the second minus 21x minus 100 equals 0. And I can factor this to x minus 25, x plus 4 equals 0. And using zero product property, I would get x equals 25 and x equals -4. Last step is to check if I can go ahead and plug this x equals 25 in here and in here. It wouldn't give me any problem because here 25 minus 21 is positive 4. So 25 is a valid answer. However, -4 is not. -4 is not because I cannot plug -4 in here nor in here. Okay. Negative numbers are not part of the domain of logarithm. Let's do another, maybe something with natural logs. Go to the next page. How about natural log of x plus 1 minus natural log of x equals 2? So of course I can rewrite this as natural log of x plus 1 over x, since this is a minus in here, equals 2. And I'm going to remind myself that natural log is log base e. So I have x plus 1 over x equals 2. Now I know that this base to this power, in other words, e to the second power, must equal x plus 1 over x plus 1 over x. Multiplying both sides of this equation by x or LCD will result in e to the second times x equals x plus 1. I'm trying to solve for x, so I'm going to group my x's on the left-hand side, subtract x from both sides of this equation, minus x will result at, continue here. Notice that this is a product. I cannot combine this e squared times x with minus x. I cannot do that. So this becomes e squared times x minus x equals 1. Now I can factor an x out. I get e to the second minus 1 or equals 1. And finally, x equals 1 over e to the second minus 1. And so that approximately, I have to say that 1 divided by e squared minus 1, okay, 0.157. That's good enough. Okay, let's do another example. How about something just a little bit more interesting? Suppose I have log base 2 of x plus 1 plus log base 2 of x plus 7 equal 3. Okay, first I'm going to rewrite this as log base 2 of x plus 1 times x plus 7 equals 3. Now I know that this base to this power must equal all this. So I'm going to rewrite this 2 to the power of 3 equal x to the second plus 8x plus 7. Okay. All right. So now I have 2 cubed is 8. If I subtract from both sides, I will be having x squared plus 8x minus 1 equals 0. Gosh, no, I can't factor this. So I'm going to have to use quadratic formula. So let's say that x equals opposite of b plus and minus square root of 64 plus 4 all over 2. So x equals minus 8 plus and minus, let me change color, that will be, so things don't get mixed up. X equals minus 8 plus and minus square root of 68 over 2. And let me just, okay. Let me go ahead and continue up here and say x equals minus 8 plus and minus square root of 68 is 2 times 34, and that's 2 times 17. So I can rewrite that as plus and minus 2 root 17, 2 root 17 over 2. Okay, now that I have factor of 2 in here, and in here, I can divide everything by 2, or if you want, you can think of this as saying x equals, more professional way of doing showing this would be x equals 2 times minus 4 plus and minus root 17. Okay, all over 2. Now I can cancel this. So x equals minus 4 plus and minus square root of 17. Let me grab my calculator, and that I should get 2 answers. One x should give me a negative number, and the other x should give me a positive number. Okay, so minus 4 minus root 17 is going to give me negative 8.123, and minus 4 plus root 17 minus 4 plus root 17 is going to be 0.123. And I'm going to go ahead and toss this negative because I cannot plug it in here. If I plug in negative 8.123, I get a negative log. That's not admissible. And here, it wouldn't work here either. Okay, so my only solution is minus 4 plus root 17 with the, and this is the approximation, x almost equal to that much. And let's do one last problem. How about if I had something right? Log base a. What is a? We have no idea. Could be any number. X plus log base a of x minus 2 equals log base a of x plus 4. Now notice that in your left-hand side, I can rewrite this as log base a of x times x minus 2 equal log base a of x plus 4. So now I'm going to claim that this is the same as x times x, which is x to the second minus 2x equals x plus 4. Why is that? Because this equal sign demands that since the left-hand side is equal to right-hand side, you know, log of left-hand side must equal log of right-hand side. I think I said it backward. Okay, this equal sign demands that if you have log of something equals log of, let's say, base A and B A of another box, okay? So if log of, if log of left-hand side, if log of this box equals to log of this box, then these two boxes must be of equal value. Uh, Hopefully you can think about it. If you don't agree with that, think about it for a minute and just make sure that you'll remember that. Now by rearranging this, if I subtract x from both sides, I get x squared minus 3x, and subtract 4 from both sides, I get minus 4 equals 0. So x minus 4, x plus 1 equals 0, and x equals positive 4, and x equals negative 1. And we know that x equals negative 1 is not going to work, not because I cannot put it in, you know, it's not in the domain of logarithm. So x equals 4 is the only solution that we have. I hope you like these problems, and I'll talk to you soon. Thanks.